So today we're doing hard problem 302, smallest rectangle enclosing black pixels. So we're given some binary matrix image where 0 represents a white pixel and 1 represents a black pixel. And black pixels are connected in one region, and they are connected horizontally and vertically. And we are given position of one of them and return area of the smallest axis on a rectangle that encloses all pixels. Write an algorithm that is sublinear if we pretend that number of cells is linear. Okay, so I'm in the rectangle. It's easy to find a rectangle in linear time, of course, with respect to number of cells, because it's minimum x, minimum y, and maximum x, maximum y. Now how do we find this? Well, we got the position, and that's the key. So if we got the position, let's say this one, so what we need to do is first let's find the range of columns. But now I'm wondering, because question is, can you get like there is only one black region. Pixels are connected horizontally and vertically. Because I mean, if you get this, then that kind of sucks. I mean, I'm not sure. I mean, one component, but you know, could that component be this? I don't know, let me try. Because what I was thinking is that, I mean, if it would straight up just be like, there wouldn't be gaps, then I guess we could do it, but okay, I mean, that's possible. So I mean, we need to find because there is just some range of columns, and in adjacent columns there is okay, so basically we want to find the first column where there is at least something set, right? And how can we do this? Well, we can, with binary search, we find that column, and for a certain column we just go top to bottom and check if at least one is active. Basically we do projection of cells onto x-axis, so first principal component or whatever. Not really, but whatever, right? So that gives us left boundary. Similarly for right boundary, we go from here to here, and then we find last column with at least one, and then we know left and right in like what, n log n, if n is number of columns, and then same for top bottom, and we are done. So Okay, let's do that. So we need to do binary search 4 times. That's interesting. While this, and then we do any is equal to any, or like if any x is 1, or like cell, or like value, whatever. So value, or no, that's like image. We are at mid, and y value is this for, nah, y value is mid, or no. What's x? What's 0 to? I think they swapped it. Okay. Okay, so now x really means columns. So first we are doing it on the columns, so this is y, and then no, right, so if anything in that column is that, then we are like, okay, that's my column, else that's not my column, and then we do like left is equal to L, and then LR x m minus 1, m is this, whatever, if any image I m 1 for I image m, L is m, else we want yup, and if you have two options for binary search, either L is m plus 1 or L is m, and this is m minus 1. In that case you do plus 1 here because you will get stuck, and then right is equal to L, and then we do 2 more binary searches because why not? Okay, so that will be from 0 to y. I mean, I can straight up just copy entire thing, I guess. So let this be that, and this will be m j for j in each column. So this is, we are looking for first row, right? So for a given row we go through entire row and check if it's active. And then here we do this, and then this, and then this, and then this, and then we just return like bottom minus top plus 1 times right minus left plus 1. Doesn't work for some reason. Print left, right, top, bottom. Let's see. That's weird. Oh my days. Right, so x, that's mid, so we are looking for a column and like that, and this we are still, but we should be for okay, and like that, and like that, and that maybe will work. N M least index out of range. I mean, what? this is image for each row. I mean, what the hell? Because this is, we are going through all rows. Okay, I'm done. So let's do n here. Excuse the dog. So what are we doing again? I'm so confused. So here we are looking for, I hate xying here, that's ridiculous. So I swapped x, so that means that we are looking for, because when they say x0 and y2, it should be this. So y is column, but isn't x column, so I swap it, right? So we go up to 0, 2. So first we check 1, column 1, and we go for all in that column, right? Here we go up to column, okay, and all in row we check, and here we go like this, okay. Wasting time, garbage. Anyways, so one space, and this time, right? So the bounding rectangle, the smallest rectangle, by finding its boundaries, which are minimum x and y positions and maximum. Okay, how can we find them in sub OMN time? Suppose we want to find the first column with any 1. So if we want to first, let's swap x and y, since the problem has them confused. Now with any pixel, which we can do now. Suppose we have an array where active I means there is exactly one cell with there is at least one cell, at least one black pixel. Notice that since the black pixels make a single component, the ones in the active array form a continuous subarray, meaning if we know at least we know position of one of the columns, we can simply binary search for the first column that has at least one black pixel. Okay. Each iteration of the binary search can just go through the entire column, okay, to check if it has at least one black pixel. Find the last active column in a we can also find the last with now find the top and bottom bounds of the rectangle. We do the same thing, but we are looking for first active row and last active first and last active rows. Finally, the rectangle is right, left plus 1 c dot bottom top plus 1 o m log m plus n log n, since we do log m iterations when looking for first slash last active row, and each iteration takes it's I guess like this, which takes on to go through the entire row. Similarly, to find the first last active column, we do O log n, and each iteration takes O m to go through the entire row. Okay, let's see if I'm not confused on this. So we are looking for row, and for each of them we go through all the columns, so the entire row. Well, whatever. Okay, I mean 20 minutes for this is a lot, but see you tomorrow.